Hey, what's up, guys? This is Chung. So today, let's take a look at this week's weekly contest problem 1744. Can you eat your favorite candy on your favorite day? Um, this one got a lot of downvotes because the description is kind of a little bit confusing and there are like a lot of edge cases. So you're given like a zero index array of positive integers candy counts, where the candy counts I represents the number of the candies of the ice type you have. And then you're also given like queries. So the queries have like three uh, item. The first one is the candy type you want to eat, and the second one is the date you want to eat this type. The third one is the daily cap, which is the maximum candy you can eat per day. And then you're following this rules to eat the candies. So the first one is you start eating candies on day 0. So remember the days also starts from 0. It's 0 based. It's not 1 based. And the second one, you cannot eat any candy of type I unless you have eaten all the candies of type I minus 1. So this is the the condition that I misunderstood during the contest. Basically, I thought, this one all candies of type I minus one. I thought as long as you eat at least at most one candies per type, you can eat the ice candy, right? Which means that that's why I got confused, by this like examples. So this one means that I want to eat candy type 1 on the third day, on day 3, right? And then I was like, okay, so since we have 5 type zeros, right? And then we can just simply eat one candies uh, each day, right? From day 0, 1, 2, we just eat the type zeros. Then on the third day, on the day number 3, we can just eat the candy 1. But this all means that, to eat the ice candies, you have to eat all the count of the I minus ones. Basically, when you start eating ice candy, you cannot have any candies before I left. So this is the part that you need to be careful. And second, the last one is that you must eat at least one candy per day, right? And then it just asks you to return like an answer, like a Boolean values for each of the queries. So here are some examples, right? We have like this is the list of candies, and here are some queries. And so for the first one, right? So the first one, on day number 2, right? On day number 2, we want to eat candy type 0. And on each day, we can eat at most 2. So this one certainly it works because we can just eat one candy at a day, and on day number 2, we can still eat candy 0. So for the second one, the since we want to eat candy type 4 on day 2, and on each day we can eat four candies at most. So which means that let's say on day 1, right, we eat four candies of type 0 on day 0, okay, and on day 1, right, we also eat one of the remaining three candy zeros plus one of the candy 1. But on day 3, on day 2, we cannot reach the candy type 4 here. So that's the description of the problem. And here are some constraints, right? Okay, cool. So for this problem, I think it's kind of straightforward that, since we can eat at least one candy a day, right? And at most this cap, at most this cap per day. So with these two like a start and end like point here, we can just calculate the maximum days. Basically, the last day we can eat the current candy type, and the minimum days, the last day that we can eat this favorite type, and the earliest day that we can eat the candy type. And as long as the current day is within this two range, right? Then we can simply return true. Otherwise, of course, obviously it's false, right? So, and how can we calculate these two values, right? So for the last day, obviously, for the last day, I mean, of course, we want to eat. It means that we will eat candies, uh, one one candy per day, which means that, let's say we are trying to eat uh, here candy 0, 1, and 2. So what is the last day we can eat candy type 2, right? So how many days we have? How many counts we have? We have 7 plus 4 plus 5 equals to this is 16. So which means that, the last day we can eat candy type 2 is 16 minus 1, which means it's 15, because remember the days is 0 based and the count is 1 based. That's why the last day we can eat the candy of this one is 15. And how about the earliest day, right? So the earliest day, of course, is that we always eat the candies the same as the cap. So, and what's going to be that, right? So again, we have 16. We have 16 counts. Uh, sorry, not 16. Oops, sorry. I think so this is 0, 1, and 2. So to be able to eat type 5, right? So we have to finish eating all the previously uh, candies, which is what? Which is 7 plus 4 equals to 11. And let's assuming the cap is equal to let's say the cap is equal to 4, which means that we can eat at most 4 candy a day. So of course, if we to calculate the earliest day, right? The earliest day, we'll use this 4 to eat the candies. And what is the earliest day we can eat the type 2 here? It's gonna be the 11 do a modular of 4, which is in this case is 2. This means that the earliest day we can eat candy, the current candy type 2 is 2. So remember, so here we are like doing the modulars, but the reason we can use this one is because remember the day is still one base, so which means that, if on days 2, which means we are on the third day actually, right? Because we're starting from day 0, day 1, and then for the first 2 days we already eat like eight candies, right? And then for the on day 2 here, right? Even though we still have some numbers, we have 3 candies of the previously one, but we have like one more candies. We have the last candies that for the current type, and that's how we calculate the minimum, the earliest day, and the and the last day. And then we simply check if the date, the current date, right? If this favorite date is between those two values. Cool. So the coding is it's very short actually. So oh, and one more thing, right? Since we need to use the we need to get the pre-sum, right? The total count for the to the current one and to the previous one, which so common strategy we use a pre-sum, right? So for me, I prefer using this one to do the pre-sum so that we can handle the we don't have to do the I plus one enumerate. Okay, candies count, right? So the pre-sum is I, so C plus pre-sum of I minus one. Then we have type, we have the day, right? And then we have the cap, the daily cap. So I'll just use cap here. Inquiries. So the last day, right? So the last day we can eat the type the, the t the type t of the candies is the pre-sum of like the t minus one, like right. And then the earliest day, the first day, right? The first day we can eat the t is going to be the pre-sum of t minus one because we need to eat all the values, right? All the candies before t, which is t minus one. And then we do this by cap. And then we just do answer dot append minimum, sorry, not minimum, first day, and this one day, last day. That's it. Okay, so submit. Yeah, so that's it, right? I mean, the obviously the time space complexity is just the O of n. There's only one for loop. So yeah, that's it for this problem. You know, mm, the conditions, right? You have to read it very carefully. You know, so and this one has like a lot of conditions or parameters. We have this type, we have this day, and we have this cap. So as long as you can understand all the conditions, and and then I think it should be pretty straightforward to find the range, or at least two conditions to check if the current D is can be satisfied, right? And the last one is that you have to be careful, right? Spend a little bit of time like trying to write some like examples for this kind of last day and the first day because the days is zero based and but the count is one based, so you have to do some like minus one and here do a flooring, but you don't have to do a minus one plus one, right? And other than that, I think that's it. And I think that's everything I want to talk about for this problem. Mm. Cool. Thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.